Hi everyone, this is Mrs. Ruscio and you are watching the Applications of Inequalities Notes video. In this video, we're going to take words and put them into inequalities or systems of inequalities. So let's dive right in. Number one, we're going to translate the following expressions into an algebraic inequality. All right, so A, half of x, so half of x is at most. Now, a lot of people want to think that that's a greater than symbol. That's a less than or equal to because you can't have any more than that. So it has to be less than or equal to 5 less than y. You've seen this language before. This is y minus 5. All right, B, 2 more than y. Okay, again, 2 more than y means we're starting with y, but we're adding 2. And this says is at least. So that means we can actually have more than or equal to something. Greater than or equal to 3x. That was a nice review. You can go back to, I think it was the first day of notes where we talked about all of these different types of inequality keywords. Okay, let's look at number 2. A local soccer stadium charges $16 per adult ticket and $8 per student ticket. They had at least $1,600 in sales. It says right in inequality. I love when they say that. And I also love the fact that they told us that adult tickets are X and student tickets are Y. So actually, I'm going to color code this. Adult tickets are X and student tickets are Y. So that also helps us when we graph this as well. So if I write an inequality here, I have $16 per adult, so $16 per X, plus $8 per student ticket has to be at least, so greater than or equal to $1,600. I could solve for I could solve for y and then graph it that way, getting my slope and y-intercept, but I just want to show you how this works with technology. First, change your graph to relation mode because we don't have a function here. We have an inequality. 16x plus 8y, and then control equals gets those inequality symbols, is greater than or equal to 1600. Now, you might hit enter and panic and think, oh my gosh, it's not there. It's there. It's just, we're looking at their scale. Our scale is so small. Like right now, we're going up to 6.67. We have to go all the way up to 230. Look at the graph. Look at those clues. I love that. So 230, I'm going to tab to get to my x value because that also has to change to be 110, maybe even a little bit bigger. Now we're talking. All right, now we're going to trace this, but let's be careful with our tracing. We always change our trace step and we usually change it to 1, but I'm looking at my x scale and it's counting by tens. So count by tens instead of ones. We're still going to get plenty of points. All right, now menu, trace. You guys should get the hang of it by now. We've been doing this all year long. Beautiful. We're graph tracing this bad boy. Here we go. 0 to 100. We're going to start plotting some points. What else? 10, 180. So 10, 180, 2, 160. And I'm just going to follow this pattern as we go. Love it. Now we're graphing an inequality. So we need to decide, is our line solid or dashed? As you can see over here, it should be solid. Oops. So this should be a solid line. And I'm going to wiggle my mouse over here. Oops, I have to escape first. Now I can see. See how when you wiggle your mouse, it makes it bold? We are in good shape. We are a solid line. And we're shading above. Okay. I also like to label because it's good to get into the habit of this, especially when systems come along, because if you forget, that's where the points get taken away. All right, what is one combination of tickets that can be sold? Well, the sky's the limit here. I mean, we have infinitely many solutions. We have not only a solid line, so any solution on the line is going to answer the question and make the inequality true, but any other point on the graph in the shaded area will. So let's see. I'm going to pick this point here, 80, what is that? 60. So 80, 60 is a nice start, but let's explain. 80 adults, because that was our X. So 80 adult tickets and 60 student. This is important to relate it back to the context of the problem. And I wrote tickets as TIX to abbreviate to save some time. All right, example number 3, Jane. She is selling apples and oranges. She has to buy the fruit from the grocery store first. She's going to pay $2 per apple, $3 per orange, and has $18 to spend. Together, she can sell a maximum of 12 pieces of fruit. Write a system of inequalities. Okay, so we need 2 inequalities. So if we have 2 inequalities, that means we have 2 variables. So I'm going to bring in X and Y. And to me, I need to figure out the number of apples, right? Isn't this what we're trying to find? So the number of apples, and then the Y can be the number of oranges. Okay. Now let's see. I think you guys know what to do from here, right? Because it's $2 per apple. So this would be a money inequality. So $2 per apple plus $3 per orange. But Jane only has $18 to spend. So we know that this is going to be 18 over here. She has to spending is on the left side. She has to spend less than or equal to $18. Then she has a maximum pieces of fruit, or like the number of fruit, and that means that she can only buy up to 12 pieces. So again, less than or equal to those 12 pieces. And what would that be? Well, the number of apples plus the number of oranges should be less than or equal to 12.